Hi! We are now moving on to what we call formal deduction. Formal deduction is it's one of the I really enjoy formal deduction, but I've also found that students really hate formal deduction. I shouldn't say that because that might suggest or predict a negative reaction. But what I like about formal deduction is with truth tables, we're taking and we're sort of looking at how these statements can be true and how they can be false, and comparing statements and using that to test validity. But with formal deduction, we're actually going through the process that your brain goes through, the way you think these things through to reach the conclusion you want to reach. And so the idea here is that, you know, you have an argument and you say, well, if Bill's there, then I'm not going. Well, Bill's there, therefore I'm not going. That's what we call modus ponens. And we can do that, and then we can add on a simplification, and an equivalence, and a De Morgan's rule, and we can add all these rules together, and we begin to find that just starting with a couple simple statements, we can say all kinds of stuff in all kinds of different ways. Like if I say, you know, like I say to my son all the time, if you don't, I don't know all the time, but you know, something like, if you keep hitting, well, my son's 2.5 and 1, so my 2.5-year-old will often say, if you hit your brother again, then you're going to time out. And he'll say, he'll be like, he'll just look at me and he'll proceed to, you know, hit his brother, bite his brother again. And I will then say, you hit your brother again, or you go to time. If you hit your brother again, then you go to timeout. And I can say that again, but a lot of times what I'll do is I'll switch it by a rule of implication. I'll say, either you don't hit your brother, or you're going to timeout. Do you want to go to timeout? No. All right, then what do? We don't hit our brother. And that's essentially taking a statement via a rule of implication, which we'll talk about here in a couple of lessons, and basically saying that an if-then statement is the same as saying that the antecedent is false and the consequent is true. And so what you learn is you learn that these statements that probably make sense to you, either you don't hit your brother or you go to timeout, or you don't clean your room or you can go out with your friends. Some of you might, you know, sort of think of some of these statements. Maybe your parents said, I don't know if they told you not to bite your brother or hit your brother, but the if you remember that, but the case is that that we can then sort of follow that and see where it can go. Now there are 18 rules that we'll learn. There are 8 rules of inference, which is sort of the inferential process, and then there are 10 rules of replacement. And the rules of replacement are basically rules of what statements mean the same thing. What I was giving you was a rule of implication, that an if-then statement is the same as the negated antecedent or the true consequent. And that is an example of a rule of replacement, where we can say, well, these two statements mean the same thing. If we were to do a truth table, we would find that they are logically equivalent. Now, there are 18 rules, and so that can be a little bit of a challenge. But if you go on the page just below this video, there is a link to the logical rules for proofs, and I would suggest you print that out. There's a PDF of that, and that will give you all 18 rules and will help make it a little bit easier. Now, I've also sort of broken down the rules into whether or not they're rules or places. Tried to keep it a little bit simpler, because what happens is when I've taught this in the past, we get all these rules and then we start throwing them all together, and 18 rules becomes very complex. And I think the idea here is that we want to accomplish out of this is that we kind of learn how these rules work and how these things work, and not necessarily be able to move on to the level of, you know, being able to solve major logical proofs. And so what I've done is I've actually simplified some of the material. I think the book goes very quickly into some very complex material. And so what I've done is I have created a bunch of problems that are simplified. And you can click the PDF and you can print that out, and you can do those as you work your way through the lessons. I still like you to read the book, but you don't have to worry about doing the problems in the book as you have in the past. Why? Because I think the problems in the book aren't going to greatly aid your understanding. I think they'll get too complex too quickly, and they'll go beyond what we need. So if you do the problems in the lessons, and you do the problems I've created and watch the videos I've created, then I think you'll do that will be a better way to go. Alright, so read the book, do the lessons, but then the videos and those lessons, as far as the ones I've created, those are the ones that are more important. Those have been simplified and they're a little bit easier. So if you'll look down, I have created sort of a protocol for how I want you to approach this. And the way I want you to do is read the book, read the first 7.1 to 7.3, watch or read through the first set of lessons that were created by the previous instructor, and then watch my 2 videos. But actually I want you to watch my first video and then do the problems, watch my second video, do a few more problems, then do lesson 2 and read the 7.4 from the book, watch the rest of my videos, and then complete the last set. And the last set is a very long set of problems. Now, if you don't want to do all of them, if you want to look at the answers, I've provided those in the same link. If you want to look at the answers, if you kind of feel like you're getting it and you kind of want to just scan through it, I'll be okay with that as long as you're comfortable with it. I gave you enough problems so that you're comfortable and ready to take the exam. Alright, I hope that all is going well, and if you have any questions, don't hesitate to contact me.